This lesson is for 1.4 Equations of Lines and Modeling. So the first question that we're going to start with kind of goes off of 1.3 as well. So we have a slope of -7/9 and a y-intercept of 0, 16, and we want the equation of that line. So if you remember, we're talking about how we use f of x equals mx plus b to be the equation of a line. That's slope-intercept form. Since we have both of those numbers, we can just plug them in and say f of x equals -7/9 x plus 16, because that would be our y-intercept here. And so those problems are really easy when they give you the slope and the y-intercept. For the other kinds of problems, I would really like for you to use point-slope form, and here's your point-slope equation. It says y minus y1 equals mx minus x1. What you will need, what you will always need, is the slope, because you need to be able to plug that in, and then a point, and that x value and y value are where this x1 and y1 are. So again, you always need a slope and a point. Those two things are what you need. Okay, so let's do an example where we use this point-slope equation. We want to find the equation of a line that has a slope of -2/3 and contains the point -3, 6. So this is the two things I was just saying we need. We have this slope and we have this point. So what I do is I write it out like it has holes in it, and I just fill in the holes. So the slope is -2/3. I'm going to stick that here. And then the y value is 6 and the x value is -3. So you can leave it like this, or you can work on it a little bit, because obviously two negatives will make a positive. And I can distribute this through and get -2/3 x plus -2 or -2, and then add my 6 over and get +4, and then I'm in slope-intercept form, which is, really useful to graph with. Plus I know my y-intercept is 4, and I can again still see that the slope is -2/3. So I just think that the point slope is really useful for that kind of problem. Alright, here's another kind of problem it's useful for. This one gives us 2 points, but we need the slope and a point. So you have to figure out the slope first, and even if you were trying to do this another way, you would still have to calculate the slope. So you're going to do y minus y over x minus x, and so that's going to give me -7 over -1, which would be a +7. If you're using point-slope form, you can use actually either point. So your slope's going to go in front of the parentheses, and you just pick whichever point you like. Some of you might like to use this point because 1's easy to work with. Some of you might like to use this point because you don't like negatives. So I'm just going to go with the 3 and the 2 this time. Just make sure you put the y value, which is the 3, with the y, and the x value, which is the 2, with the x. And then, again, you can leave it like this, or you can go to y equals mx plus b form to help you out. So I'm going to go ahead and do that and get 7x minus 14, and then add the 3, 7x minus 11. So I can see what my y-intercept is in this slope-intercept form. Okay. Next thing, you've probably not dealt with in a while, but you probably have seen it, is parallel lines and perpendicular lines, how to tell the difference in those and just everyday pairs. So if lines are parallel, they're going to have the same slope. They're going to have different intercepts. So even if they're vertical lines and their slopes are undefined, they would go through different points. Otherwise, they would be on top of each other. So same slope is the big deal to remember. Perpendicular lines, you were probably taught flip and multiply or negative reciprocal. Your book gives this definition that they would multiply to equal -1, and I kind of like it because, for example, if I had something with a slope of 5 and something with a slope of -1/5, those are perpendicular, and you may recognize that as being the negative reciprocal of this one, but if you multiply them together, you get a -1, and that's an easy way to check, to be honest, so I'm probably going to try that out. The other case that doesn't really fit with that, because the slope of a vertical line is undefined, is this horizontal and vertical line. Obviously, if you have a vertical line and a horizontal line, they're perfectly horizontal and perfectly vertical, then they are perpendicular to each other. So we have some examples here, and we're going to determine which ones, whether they're parallel, perpendicular, or neither, because lines can just cross and not be perpendicular. So they don't always have to be parallel or perpendicular just because that's what we're studying. So we're going to see what these are. The first thing is I need all of this in y equals mx plus b form, so I'm probably going to have to put a few more spaces in here. Okay, now, so we need to get them to slope-intercept form just so that we can determine what the slope is. So I'm going to get y by itself in this one by subtracting 2. So I have y equals 5x minus 2. So the slope of this one is 5. When I come over here, I need to subtract x. So I have 5y equals negative x minus 15, and then divide by 5. And I get y equals, that's going to be a 1 right there, so that's a negative 1/5 x minus 3. And wouldn't you know it, it's the same exact example that I just came up with up there. One has a slope of 5, one has a slope of negative 1/5. And if you multiply those, you get negative 1. So these are perpendicular. Okay, for example B, again, I've got to get it in y equals mx plus b form. So I'm going to, in the first one, subtract 4x to the other side. So I have negative 4x plus 8. Then I'm going to divide by 2. So I get y equals a negative 2x plus 4. Now this one over here, it's backwards, but all I need to do is really divide by negative 1. So I'm going to write y, and then I'm going to divide by negative 1. So I get negative 2x minus 5. And if you're unsure of what I just did, raise your hand. I'll help you out. And in this case, we look, the slope of this one's negative 2, and the slope of this one's negative 2. Since they're the same, these are parallel. Okay, lastly, we have example C, and the first one is already in slope-intercept form. It's just turned around. We tend to, put the y on the left-hand side, so I'll turn it around and make it look pretty for you. Y equals 2x plus 1, so the slope of this one is 2. To this equation on the right, I've still got to get the y by itself, so I need to subtract that 3x, and I get y equals negative 3x plus 4, and so the slope of this one's negative 3. Well, they're obviously not the same, and if you multiply 2 times negative 3, you get negative 6, which is not negative 1. So this would be a case where it's neither. They're not parallel, and they're not perpendicular, so you just put neither and move on. Now we're going to kind of combine the things that we were doing in the beginning with the parallel and perpendicular. They're asking us to write the equations of lines that are parallel to and perpendicular to this equation and going through this point. So that's a lot to cram in. I'm going to kind of separate it when I'm working. Do the parallel over here and the perpendicular over here. They both have to go through this point, so I need the point 2, negative 3 for figuring out both equations. I also need slope, and it has to relate to this one, this 4y minus x equals 20. So I need to get that in slope-intercept form. So I'm going to have to add the x and then divide by 4. So I'm going to get 1/4 x plus 5. So the slope that I'm trying to match or change a little bit would be 1/4. Parallel, we know, is going to have that same slope, so I'm going to write that down. I need a 1/4 slope. Perpendicular, you have to think, what can I multiply by 1/4 to get a negative 1? So obviously it's got to be negative, and then for the 4's to cancel, it's got to be 4. So the slope for your perpendicular is negative 4. Then you're doing what we did in example 2, I believe. So I'm going to use point slope form. and I'm going to plug in my y value, my x value, and my slope. Then I'm going to change this to a plus because two negatives will make a positive. I'm going to distribute in, and 2 times 1/4 is going to be 1/2. And then I'm going to subtract the 3, which is 6/2, so I have minus 7/2 here. And now I'm going to do the perpendicular side, same way. So y minus blank equals blank, x minus blank. Y value with y, x value with x, and the slope in the front of the parentheses. So again, two negatives make a positive. I have y plus 3. Distribute, I get negative 4x plus 8. Then subtract 3, and I get negative 4x plus 5. So this line would be parallel to the original. This line would be perpendicular to the original. Okay, now we are to the mathematical model portion of the notes. And this is when we're trying to, we have a real-world problem and we're trying to describe it with mathematical language or give it an equation. Curve fitting is actually trying to fit that function, that equation, to that data set. So I've sketched out some scatter plots. This one looks linear, so if we would be trying to come up with a linear equation that hits most of those points, that's curve fitting. And over here I would look at it and say, okay, something with a curve. I might say exponential, I might say quadratic, and based on that observation I would try to come up with an equation that catches most of those points. And so we're going to do a couple of examples. This first one we're going to do by hand. I know you're probably used to doing it in your calculator, and I'll remind you how to do that. Okay, so we have the cost of a 30-second Super Bowl commercial has increased 1.6 million from 2010 to 2015. Model the data in the table with a linear function by hand, and then estimate the cost of the 30-second commercial. Okay, this table actually comes from your book on page 55, and you can see everything in a little more detail. So these are the years, and they want us to use 0, 1, 2, 3, 4, and 5 instead of 2010, 2012, whatever. And then this is the cost in millions of dollars. So again, if you want to see exactly how it looks and everything, and they have the scatter plot in there, it's on page 52 of your book. So they want us to write a linear equation that models this data and then use that to estimate. So you have to pick 2 points, and it can be any 2 points. So I'm going to pick this one and this one. Okay, so the reason you need 2 points is, again, because we're trying to come up with the equation of a line, and you need to know the slope and at least 1 point to be able to put it in point-slope form. So let's use these 2 points to figure out the slope. So I'm going to have y minus y over x minus x. Okay, and if I use my calculator, that's going to give me a 0.3. So then I'm going to set up my point-slope form of a line and put my 0.3 in front. And I can use either point that I want to, so I'll just use the first one. The y value is 3.1 and the x value is 1. And then I can distribute and get 0.3x minus 0.3, and then add my 3.1 over and get 2.8. So here is a line that models this situation, which is the first part. They ask us to estimate the cost in 2018. So 2018 would be year 8. So I'm going to plug in 8. So y would equal 0.3 times 8 plus 2.8. And then that outcome is going to be 5.2. So the estimate is that it would cost $5.2 million in 2018. Okay, linear regression is when we use the calculator to help find the equation instead of trying to do it by hand, because even though we did that one by hand, it's not perfect. It's not the best it can be. And a calculator helps us because it finds the absolutely best line that would go through the most points and fit that data perfectly, or as close to perfect as possible. So we're going to repeat this problem, and we're going to use the linear regression from our calculator and estimate. So what I want you to do is to get your calculator and go to the Stat button, S-T-A-T, and it should be on Edit, so you hit Enter. If there's something in your lists, go up and get on L1 or L2 and hit Clear Enter, don't hit Delete, and they will clear them out. Type your X's in list 1, so 0, 1, 2, 3, 4, 5, and then your millions of dollars for your commercial in list 2, so 2.9, 3.1, 3.5, 3.8, 4.0, and 4.5. Once you've done that, hit Second, Quit, and then do second. Excuse me, don't do second. Hit Stat again. Pardon me. So after you have your list entered, hit Second, Quit, and then hit Stat. Scroll over on the top, you see Edit, Calc, and Test. Scroll over to Calc and go down to number 4, which is LinReg, standing for linear regression. And it should have list 1 and list 2 listed. Just arrow down till you get to the bottom and hit Calculate. And when it comes up, it gives you A equals 0.314 and B equals 2.847, and it gives you a whole bunch of decimals, but you don't need that many to just try to get it right. So that means that my line would be 0.314x plus 2.847. And so to estimate year 8, now I just plug in 0.314 times 8 plus 2.847, and let me see what that gives us. And I get 5.359. So that was the estimated cost using a better line than we came up with by hand. Now, correlation coefficient is an R value that is between -1 and 1, and it appears when you're doing that linear regression that we just did. So if you saw A, B, and R, then you're good. If you didn't see the R, and I didn't see the R on mine, hit second 0, and then your catalog comes up, and you want to scroll down until you get to diagnostic, and you can shortcut it by hitting that green D button, and scroll down till you get to diagnostic on. Hit enter twice, and then that means the R will come up the next time that you do a regression. It should show up once you have hit enter twice with diagnostic on. If you need help finding this, raise your hand and I will help you. Okay, now I want you to look at the graphs on page 55 because they're kind of hard for me to draw on here. It gives you examples of correlations that are strong and weak, positive and negative. Positive correlations go uphill, negative correlations go downhill. If it has no correlation, which may happen, they're just kind of all over the place. But the closer they are to the line, the higher the R value is toward 1 or -1. And the farther they are off the line, you have a lower R value. And so the higher your R value is, or like the absolute value of it. So you want to be close to 1 or close to -1 to be a strong relationship, a strong correlation. What that means is you have a really good fit. Your line that you came up with is really good for the data. And so that's important to know, and that is the conclusion of this lesson.